Okay guys, we're going to go ahead and start talking about chemical bonding today, and this is just an introduction to chemical bonding. Now, what a chemical bond is, the formal definition of it is it's a mutual electrical attraction between the nuclei and the valence electrons of different atoms that bind the atoms together. Okay, we know that atoms, they rarely exist alone. They don't want to be by themselves. They want to be bonded to something, because when atoms bond together, they have less potential energy and they're more stable. Okay, now what this means, what potential energy is, it's stored energy, it's backed up energy, it's energies that they have in reserves. And basically, it wants to have less potential energy. It wants to be stable. It don't want to have so much energy. So it does this by the sharing and the transferring of valence electrons. Now, the first type of bond that we're going to talk about is an ionic bond. Okay, and the basic definition of it is it results from the electrical attraction between large numbers of cations and anions. And what this means, remember that cations we talked about in chapter 5. A cation is a positively charged ion. And remember that cations are normally metals, okay, because they give up their electrons readily. They want to get rid of them because it's easier if they get rid of them to have 8 valence electrons. Now, anions are nonmetals. They're the exact opposite. Those are negative ions. Now, what basically happens is that one atom donates or accepts electrons from the other. So usually what we see is we see the cations, which are positive, they're going to donate their electrons. The metals donate their electrons, and the anion accepts it. It takes that electron. And that's the basics of an ionic bond. Now, the next type of bond we're going to talk about is a covalent bond. Now, a covalent bond results from the sharing of electron pairs between two atoms. Okay? Now, the electrons shared belong both to each atom. Okay? So what we see is we see the pulling and tugging of an electron kind of going back and forth. And they do this again. Remember that all chemical bonds are just trying to get 8 valence electrons. Now, there are two types of covalent bonds that we're going to talk about. We're going to talk about a polar covalent bond, and we're going to talk about a nonpolar covalent bond. Now, a polar covalent, which you can see over here, it's when an electron is shared unevenly. Basically, what you can think of it as is you have one electron being a bully, or one atom being a bully, and it's pulling all the electrons to one side. So we see that in this atom, or this molecule, covalent bonds are called molecules, that the electrons are shifting to the right, and this side is holding most of the electrons. So this atom right here is being a big bully and is stealing all the electrons. Now, the nonpolar covalent is when the electrons are shared evenly. So if you look at this picture, it's a nice round shape on each side, and we don't see a cone. So therefore, this is going to be a nonpolar covalent. So, recap: polar covalent, shifting of an electron to one side; nonpolar covalent, shared equally. Now, ionic versus covalent, the difference between the two. If we look at a covalent bond, these are called molecules. Now, what we see here in a covalent bond, the main thing, sharing of electrons. So they're sharing. We see that these two electrons are kind of in the middle, and they're kind of going back and forth between each atom. Now, an ionic bond, we see that we have the transferring of electrons. So we see that this electron will move completely over here to the other atom. So, big difference between ionic and covalent. Covalent shares, ionic transfers. Now, bonding usually doesn't fall into one category or the other, but somewhere in between. So something is not completely ionic or completely covalent. They kind of in the middle, and it's just a little bit of one and a lot of the other, or vice versa. Now, the types of bonds depends on the element's differences in electronegativity. Now, we talked about this in chapter 5. Remember that electronegativity is how much an atom pulls on the electrons of another atom. So we see here that the nonpolar covalent electrons are shared equally. Okay, the polar covalent, we have those unequal sharing, and then ionic, we basically have a transfer. So the bigger the difference in electronegativity, the more ionic characteristics that bond's going to have. Now, specifically, when an ionic bond is always going to be greater than 1.7. Okay? Now, if it's greater than 1.7, it's going to have over a 50% ionic characteristics. So therefore, if it's over 50%, then we consider it to be ionic. Now, polar covalent is anywhere between 0.3 and 1.7 difference in electronegativity. And we say that that has a 5 to 50% ionic characteristics. And remember, when we see ionic, we think transfer. And then we have nonpolar covalent, which we have anywhere between 0 to 0.3. And a big nonpolar covalence, guys, when you're looking at this, it's if one atom is bonded to itself, the difference in electronegativity is 0. So usually your nonpolar covalents, they're going to be bonded to themselves. Now, polarity is the uneven distribution of charge. That's where we get nonpolar and polar from. Okay, it's talking about polarity. Now, it shows the partial charges on structures by using the lowercase delta sign. Okay, and we see that the positive charges will go here, partially positive and partially negative charges will go to each specific atom. And we won't get a lot into that. We can see here, again, we have the partially negative charge here and the partial positives on the outside. So remember, when we see the partially negative, that's where the electrons are going. Okay, and again here we see that partial negative right down here. Now, let's do some practice. Now, let's determine whether each of the following bonds will be ionic, polar, covalent, or nonpolar covalent. Okay, and when we do that, we have to have electronegativity chart. What we have in front of you here, this is an electronegativity chart. Remember that it increases as we go to the right and as we move up. So, we're looking at sulfur and hydrogen. We see that they both have an electronegativity of 2.5 and 2.1. So the difference in electronegativity is 0.4, which that would be polar covalent. And then we have sulfur and cesium, and we have 2.5 and 0.7 for cesium, which would give us a difference of 1.7. So that's going to be ionic. And then we have carbon and we have chlorine. Carbon has an electronegativity of right around 2.5 and chlorine's 3, so the difference is 0.5, which would be polar covalent. And we see over here the graphs or the examples of it. Up here we see we have A would be nonpolar, B would be polar covalent, and C would be ionic. More practice, we have chlorine and calcium. When we look up chlorine, chlorine is 3, and then calcium is 1, so different than 2, which would make it ionic. We have chlorine and oxygen with 3.5 and 3, so a difference of 0.5, which would make it polar covalent. And then chlorine and bromine, we have 3.0 and 0.2, and obviously the difference between that is 0.2, which is nonpolar covalent. You can see again our pictures. Okay, so to sum it all up, what patterns we should see, remember that metals plus nonmetals make an ionic bond, nonmetals plus nonmetals make a covalent bond, and when ionic we have the transferring, and covalent we have the sharing.